Okay, today we're going over a concept you should already know, the average rate of change. The average rate of change you learned in Algebra 1. The more known name for that is slope. If it is a line, it's very consistent, but since in this chapter we're talking about quadratics, it is not consistent. I know we've talked about that the slope is 1a, 3a, 5a, but that's from the vertex. So given, if you're looking at a graph, the slope's very easy to see, but given like an equation, maybe it's not off of the vertex, maybe you don't know what the vertex is, just use the same equation you're used to, y2 minus y1 over x2 minus x1. So to use that equation, you need two different points. Whoops. And it doesn't matter which point you call point 1, as long as if you call this x1, you call that y1. If you call this x2, you call this y2. Okay, so you just plug it into this equation. On the first three, we're using an equation to find our average rate of change. So we're not given points, we're just given the x values for this graph. So if you're given the x values, you need to find your y values. So we're going to plug in -1 and see what we get out. So f of -1 is 2 times -1 minus 1, so -3. So that point that we're finding the slope for is -1, -3. That's one of them. Then we're going to do the same thing for 2. So f of 2 is 2 times 2 minus 1. So that's 4 minus 1. That's +3. And now we have 2 points we can find the slope between. So the slope between these 2 points, it doesn't matter which one you call x1 and which one you call y1, as long as if this is x1, this is y1, this is x2, this is y2. It does not matter. As long as the y is on top of the x that is paired with it, you'll get your answers right. The equation's minus, and then if you're plugging in a negative and a negative make a positive. A negative make a positive. So this would be 6 over 3, which is 2. So the slope between these points are 2, which if you go back and look at the equation, this is a linear equation. So here's the slope between any points. Since it's a line, the slope is always constant. The slope is 2. But we're not working on lines, we're working on quadratics. So let's do it again where it's a quadratic and we can't just see the slope of my equation. So this again is from 1 to 5. So we have the x's, you need to know the y's. So if I plug in 1, -1 squared plus 4 times 1 minus 1. And you can put that all in the calculator, but that's going to be -1 plus 4, that'd be 3, minus 1, that'll be 2. Right? And then we'll do the 5. So f of 5, -5 squared is 25. So -25 plus 4 times 5 is 20. So -25 plus 20 is -5. Minus 1 should be -6. And now that you have your 2 points, you can use the slope. Again, it does not matter which point you say is x1 and y1, as long as they line up. So 2 and 1 minus negative is a positive. I don't know why I made this line so long. That's okay. 6, 7, 8 over -4, -2. And it's okay if your slope comes out to a fraction, just reduce the fraction if possible. If I go too fast, slow me down. If I go too slow, speed me up. Same thing, we're going to plug in -5 and get our y value, and we're going to plug in -2 and get our y value. Okay, so -2 squared is +4 times negative is -4 plus 12 is 8, 9, 10. I think it's 10. I'll pause the video and check it in a second. So wait, I plugged in -2 instead of -5. Let me reverse those. I don't know why. So apparently I want to plug in -2 first and -5 second. Doesn't matter. So -25 plus 30 is 5, plus 2 is 7. I'm going to pause it and check those. Okay, those are right. And so now we're going to do the slope. So my 2 points are, I plugged in -2, I got out positive 10. And I plugged in -5, and I got out 7. So what you plug in is your x, what you get out is your y. But you know that because we've been graphing. So 10 over -2 minus 7 over -5. So that would be 3 over -7. So again, it's okay to get a fraction because this is slope. So this is up 3, left 7. And in a quadratic, you're going to get both positive and negative slopes. Okay, from a table, it's even easier because you already have your y values. These are my y values. So we just need to know which points we're going to find the slope between. So 1 and 3. So here's 1, here's 3. Find the slope between them. So I'm going to say this is x1, y1, x2, y2. So 16 minus 4 over 3 minus 1. 12 over 2 is 6. So my slope is 6. Same thing here, from 0 to 4. 4 minus 0. So whatever my point for 4 is. 4, what? 5. And 0, 26. So make sure you line them up. So it looks like I said this was x1, this is y1, x2, y2. So the 5 has to go on top of the 4. y1 minus y2. Or you're going to get the answers wrong. So that's negative 21 over 4. And that's it. So my points are 2, 17 and 5, 1. So y2 minus y1 over x2 minus x1. Negative 16 over 3. 16 isn't divisible by 3, so I'm good with leaving it as that fraction. So sometimes you'll get whole numbers, sometimes you'll get fractions. Okay, so that's where you to change from a table, easier than equation because it gives you the x and y. And now from a graph, if you're given the equation, you can do it how we did the first 3. Or if you're given a graph as well, maybe it's easier to see. So this is negative 1, 2. So that's one of my points. And 3. Make sure you're counting. These are counting by 2s. So 2, 4, 6, 8, 10. It looks like 3, 10. If you're not sure, you can plug them into the equation. 3 squared is 9, plus 1 is my 10. Negative 1 squared is 1, plus 1 is 2. And then that's what we're using the slope for. So 10 minus 2 over 3 minus negative 1. So 8 over 4, which is 2. If it reduces, you have to reduce it. So the slope between these points is 2. So if I was to connect a line, I'm awfully connecting a line, but I'm going up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1 to get to my other point. So I like graphing just because you can see if it's a positive slope or a negative slope. So these points, 1 something and 2 something, 1, 2, 2, 4. I think it's also a slope of 2 because it's from, actually, 2 isn't at 4, is it? I have to plug it in. 2 is actually, 2 squared is actually at 5. 2, yeah, it's in the middle, it's at 5. Thankfully, I was given the equation, so that makes it easier. So 5 minus 2 and 2 minus 1. So the slope here is 3 over 1, which is just 3. So the slope between these 2 points is steeper than the slope of these 2 points. That's true. Look how much steeper it is. So this is showing you your slope is not the same in between each point of a quadratic. Same thing. You need your point. 0 something, 2 something. 0 is counting by ones this time. 5, we're not given an equation, so we have to go off the graph. 2, 9. So 9 minus 5 over 2 minus 0 is 4 over 2. So my slope would be 2, or average rate of change would be 2. And then 3 something, 5 something, 3, 8, 5, 0. So m would equal, I'm going to reverse it. 8 minus 0, 3 minus 5. 8 over negative 2, negative 4. So this has a negative slope between these 2 points, which makes sense because it's to the right of my vertex. But these have a positive slope. And this one's steeper than that one. Okay, so you know how to do average rate of change. You've done slope all through Algebra 1. It's just now that in a quadratic, they're not always equal. All right, I hope that helps. If you have any questions, please let me know.